Hello, my name is JFoster. I am in ECE 311, 331, as well as 341, so all three of them. This is my presentation, obviously, and let's get started. So, the first thing I'm going to talk about is how this AC to DC adapter relates to what we're learning in 311. And so, what we've figured out is that you're trying to create and figure out how this circuit responds to whatever type of input signal you put into it. In this case, it's the output of the diode rectifier, which takes the AC input and turns it so that instead of being a sinusoidal input, it takes the negative half of the negative valued magnitude of the sinusoidal signal and flips it above the x-axis, so you have continuous loops on the positive side of the x-axis. And so that is the output of the diode bridge, and that's what goes into the next part of the circuit, which is a resistor and a capacitor in parallel. And so how this relates to 311 is we're trying to figure out what the response of this capacitor and resistance is, and what its response to that input augmented sinusoidal wave is. And so what we do is we put a unit step function through the capacitor and resistance, and then that gives us the step response of the input, and it ends up being a 1 minus exponential form. And once we have the response, once we have that unit step response, we take the derivative, which gives us the impulse response, which is the response if we would just input the smallest time possible a spike of electricity of infinite magnitude, which we cannot generate on its own, so we have to use this alternate way to go through this step response to get to the impulse response. And so once we take the derivative, we end up getting an exponential, and so that is our impulse response, which we then convolve with the input. And so once you convolve it with the input, that gives you, not even with the input, you convolve it with the transfer function, and once you convolve it with the transfer function, that gives you the output to any type of, that gives you a relationship between your input and your output signal that will allow you to basically take any input and use this function to determine what your output will be. And so that's about what we were doing with 331, and so I mean in 311. And so how this relates to 331 is with the diode bridge and how it all relates to that and circuit analysis. And so what happens is you have a diode bridge at the very beginning, like I talked about earlier, and so you end up getting where your input to the capacitor and the resistor in parallel is not the same as your AC voltage source from the wall. And so you have to have an augmented V-in to your system of the capacitor and resistance, which is determined through the diodes, which so it ends up being V-in minus 2 VD on, and that ends up being your new input to the system of the capacitor. And so once you have that, you're then able to more formally analyze the circuit and treat it as just a different voltage source, instead of having to do all the calculations with the diode bridge. And so then after that, then you get into the 341 stuff, which involves mostly the capacitor and a bit of the diodes. And so what's happening there is the sinusoidal, mildly sinusoidal input, the augmented sinusoidal wave, I guess, is now your input into the capacitor. And so what it's ending up doing is it's going to charge up to some function, and then it's going to decay still a bit because the diodes have not yet turned off and switched directions. And then at that point, at the point that the diode switches directions, because VD on is no longer VD on minus V in, no, V in minus the augmented is no longer greater equal to 2 VD on, so the diodes now switch off and swap directions. And so now you have the capacitor will stop charging and it will start to discharge according to its time constant, which is determined by the values of R and C. And so then it will decay until once again the input goes above VD on minus 2 VD on, V in minus 2 VD on. And so once it goes back above that, the capacitor, the voltage of V in will now be greater than the voltage on the capacitor. So the capacitor will start charging again, and it'll just follow that same output until you stop the circuit, and then eventually the capacitor will fully discharge after a set amount of time. And that is my presentation. Thank you.